Hi, everyone. Welcome to this edition of Project Pro's AI Monetization podcast, where we meet industry leaders to talk about business outcomes and ROI of AI. Today, we're privileged to have Farhat with us. Farhat is a associate VP at Mphasis. He has over 15 years of experience as a data scientist, machine learning engineer, and currently doing a ton of work focused on Gen AI. And through his career, Farhat has worked on a bunch of cutting edge technology startups, including Glance and InMobi, the leaders in online mobile ad marketplaces. And today, we're going to discuss the whole topic of code generation and code modernization with Farhat. Farhat, thanks for taking time to do this.
Thanks a lot, Vinny, and I'm really glad to be here.
You're welcome. So, Farhat, just the last week, I was looking at a video by one of our investors, Y Combinator, and the two guys who run Y Combinator, they were just saying if Gen AI can just solve code generation and customer support, if it does only that and if it fails everywhere else, that itself would have realized the humongous economic opportunity of AI. What are your thoughts on that? Does that sound right to you, just the size of opportunity just in those areas, code generation specifically?
Uh, I uh, I think that's selling Gen AI a bit short, but in terms of commercial opportunities, it does cover a fairly vast range of things that you can do, like just code generation. Like as we know, developers, programmers,
Mm,
the excellent ones are in strong demand. There is a shortage of those, and customer support is again another part, which is a huge amount of uh, like basically resources consumed from a particular company, and
mhm,
a lot of people are not really happy with it. So in terms of things that a large language model or models of these kind can do is like
mhm,
patiently talk to people as long as they need to, like without
mhm,
getting upset, without and also having a range of knowledge at the back end. So you don't have that frustration of like, okay, you talk to somebody and they hand you over to someone else because they don't know what exactly you want and so on. Whereas a single model which can seamlessly work for a person is a major breakthrough in terms of what it can do. So yeah,
mhm.
in terms of what commercially you can achieve with it and which is within the current achievable range, yes. But I think Gen AI is a lot more than that and beyond that.
Okay, got it. And just double clicking in the world of code generation, right? There
Mm.
seems to be a spectrum of solutions, possibly Copilot on one end for snippets and recipe kind of stuff. And then there's probably things like Cursor with an IDE, there's Magic, Replit, which has a agent building IDE right now. And then there's talk about IT services industries themselves having their own fine-tuned code LLMs to kind of make projects faster. Where here does code modernization fit in? Could you help us understand what does code modernization mean?
Okay, so uh, code generation means like taking de novo code. I mean, taking a, let's say, a specification of what you would like and
Yeah.
generating code that meets that. So, for
Mhm,
example, it could be, let's say, design a uh, aircraft maintenance system that keeps track of all the parts that come in and things like that. And it
mhm,
code generation part throws up code that does all of what you're asking it to do, including things
mhm,
like, say, connecting to a database, updating it once something is done,
mhm,
building a user interface, and so on. Code modernization is more specifically looking at old legacy code
mhm.
and converting it to code that works on a modern machine in a modern language.
Yeah.
Now, the question might come is that if there is already existing code, why do you want to convert it? Like it
Mm,
works fine. And the reasons behind this can be many. One is that older code, and people would be surprised to know that there is still a lot of code that has been written in the 70s or 80s or 90s and is still functioning. And most of that code is written in languages that are no longer used today, in the sense
mm,
that even if it is a language that is used today, the
mm,
version that language used today is quite different from the one that it was originally written in. And
Mm-hmm.
that means that it does not follow security principles that are in use today. The world was different back then. Uh, the kind of load that it can handle might be different. The kind of machines or the silicon that it can run on, that can be very different. So it's quite possible that you have older systems that are somehow kept working because the code cannot be used for a more modern machine. So uh, code modernization is just taking that code and
Mm-hmm.
making it work on a more modern machine in a more modern language. Now,
Mm-hmm.
the reason why it is not as straightforward as it might appear is that, firstly, this code was written a long time back. As anybody who has written code knows, uh, once you've written code, like even a few months later, if you look at the same code, sometimes it might be hard to tell without comments to guide you whether you have written it or somebody else has written it.
Mm-hmm.
And uh, when it comes to older code, the people who actually wrote that code may no longer be there. Sometimes you look at code and you're not even sure if, because code gets modified by adding extensions, patches, and so on, there might be parts of the code that are no longer in use at all, but are still
Mm-hmm.
there because nobody knows what it is doing. And that means that you may or may not want to remove it and so on. So
Mm-hmm.
code modernization broadly refers to taking old code and bringing it into a more modern framework,
Mm-hmm.
uh, keeping it functioning with all the functionalities, maybe sometimes adding more to it because your requirements might have changed and you want to take that into consideration. And essentially, that is the big part. And another part is that really old code can sometimes be in things like assembly language or so on, and you want to bring it to a modern language, like maybe it could be Python or Java, depending on the use cases that you have.
Mm-hmm.
And how do you go about doing that?
Got it. Okay. If we think about code modernization pre LLMs and post LLMs, right? Uh, I assume, I mean, we've been doing this for a while. It's not an opportunity that's opened up only because of LLMs. How is it being done right now? What kind of effort does it take? If there's some way you could pick a block of work and say this is the amount of people work it takes to do that, it'll be helpful to quantify that problem.
Yeah, sure. Okay,
Yeah.
so code modernization has been around for a long time. Like the biggest effort that a lot of people might be familiar with was the Y2K problem, where we had a lot of code that was
Right.
in older time. And
Mm-hmm.
but I mean, at that time, you never thought that this would continue existing like 20 or 30 years later. And then
Mm-hmm.
Y2K hit, and we had to modernize a large amount of code,
Mm-hmm.
which referred to years as 2 digits, and now we wanted to bring it to 4 digits. Now, that is a
Mm-hmm.
fairly specific problem at a specific point in time. But
Mm-hmm.
more broad, uh, let's say you have an old code written in a language that was particularly meant for uh, a specific use case. Like, for example, a lot of banking code exists in languages like COBOL. Now,
Mm-hmm.
COBOL was big back in the 70s and 80s, and a lot of that code still exists. Now, that
Mm-hmm.
code runs on machines like IBM mainframes, which are really expensive to work, maintain, and so on. Also, people who understand COBOL, like developers who understand COBOL and so on, are not as easy to find anymore. So
Mm-hmm.
a company like, let's say, a bank which has a large amount of existing COBOL code wants to bring that code into a more modern language, maybe wants to move from a mainframe kind of system to the cloud or its own data center or something like that, running on
Mm-hmm.
modern processors.
Mm-hmm.
So that is where they would want to do this.
Mm-hmm.
Now, the now how do you go about it? So one way that was typically done before is using subject matter experts like SMEs who would understand COBOL, SMEs who would understand the language they want to go into. So just as an example, let's say you want to go from COBOL to Java. In
Mm-hmm.
that case, you would have people who understand COBOL. They would look over the code. They would try and extract everything from that code as much as possible, and not just from the code. Like, code is one part of it, but you have to look at everything. For example, the documentation that exists, the comments inside the code that refer to what was done, when were modifications made, why were certain things the way they are, and so on.
Mm-hmm.
And you write detailed specifications about what this particular piece of code does.
Mm-hmm.
On the other side, somebody would take that specification and rewrite into a more modern language. Uh,
Mm-hmm.
in general, code modernization, except for fairly small pieces of code, is not like you go through code line by line and convert it into something else that works in another language. That sometimes works in more modern languages. Like you can take, say, Python and convert it into Julia code, going line by line, and it may work. It's not the most efficient way of writing code because different languages have their own strengths. They have their own frameworks. And if you just go about it by doing it in like even not just line by line, but if you do it like small module by small module, you'll end up with what often works, but is very inefficient. And also, it's very unreadable and unmaintainable. Uh, so that is how it is. Uh, how you would do it in a more modern world or with the use of LLMs is that you would use large language models which have an understanding of code, along with comments, along with any other details that you can give in. And large language models that have been trained on large code bases can understand these relationships between different parts of the code, and also understand things like comments and so on, and be able to infer what the piece of code does, like in terms of what are the business rules, can you extract the business rules from a piece of code, and so on. And ideally, you want to go that way. Like you're not like going line by line. What you're doing is understanding what the piece of code does, and then producing specifications for that particular piece of code, and then using those specifications, you rewrite it in the language that you want to work. So that's how it typically works. Okay, so I was saying that you don't look at code in isolation, because typically when you're looking at a large business process, it's not just one or two things that a code is doing. Like it's not completely encapsulated in a small function, which is often the case with certain kinds of programs, but most enterprises don't operate in that way. Like, for example, it might need to update databases. You might need to update a bunch of things every time, let's say, a transaction comes in, like when a bank is operating and somebody makes let's say, transfers some funds from one account to another, you need to update one person's account with a debit. You need to update another person's account with a credit. You may need to update a few other things about, like in terms of what has been done, has it happened successfully, what time it happened, and all of those. So you need to make sure that the code is interfacing correctly with all the other components of the system. It's not just about that code, but also databases. So maybe you move from one kind of database to another. So that's why you need to not just do code to code conversion, but go from code, extract the business logic, work with the business logic, and then get the modern code out.
Okay. And since you're saying the kind of intermediate step is this business logic requirements kind of not document, like some kind of a asset that has the business logic requirements, and the target code, let's say it's in Python, comes out of that. So does that mean that the large language model generating the target code doesn't need an understanding of COBOL, the source code, as long as it understands that business logic requirement? Is that the case?
Yeah, the forward engineering part, that is after the logic has been extracted, does not need to know the COBOL part. Like, yeah, so there is an integration between those two sides. Also, it's not like a complete hands-off process. You can't hand over like 500,000 lines of code to an LLM and expect it to produce working code at the other end. What you expect is that the work of SMEs is significantly reduced. The error rate is significantly reduced. So instead, if it was like 20 person years before using large language models, maybe you expect it to take like 5 person years after, just to give some numbers. It will never be, or at least right now, it will never be a case where you can just hand over code to a model and expect working code at the other end. So what you have is that what you would want is that somebody reviews the logic that has been extracted, goes over it, makes sure that it is correct, makes additions or changes as necessary, and then you hand it over to the forward engineering part, which converts it to a modern language. And then, of course, the regular software testing and evaluation and all of those will happen. So it's not a hands-off process by any means. But what it does mean is that using AI, you can significantly reduce the amount of time. So you can do it faster, you can do it more accurately, you can do it with less errors and so on.
Okay. Okay. Makes sense.
Also, as I said, like one big thing oftentimes is that with the legacy code, we may not always have people who understand the code anymore.
Mm,
So that uh, reducing the requirement for that can mean you can move much more faster.
makes sense. Makes sense. As you go through this process, like what other challenges do you think the one encounters? Earlier when we were speaking, you spoke about the security challenges, but if you could maybe speak a little more about that and what other challenges does one encounter?
Uh, okay, so some of the things that you may encounter is different parts of the code may contradict each other. So
Mm,
that can happen in a large code base. It's possible that something was added at one point and then requirements change. So you add something else. You instead of removing that piece of code, you just comment it out or something like that.
mm,
That can sometimes be challenging. Another thing that sometimes happens is that comments are different from the code. Like somebody updates the code but
mm,
doesn't bother to comments. That as
right.
as programmers would know that this is something that happens. You
Mm,
uncode, and the point where it works is where you might stop without bothering to update it. And if your code practices are good, and thankfully a lot of the older code was written in a much more deliberate fashion,
mm,
so that means that the comments are good and so on. But it's not always guaranteed. It can happen that your comments are saying something and the code actually is doing something else. Those kinds of
mm,
things can
mm,
challenging. Um, in terms of when it comes to languages that are not as expressive, like for example, COBOL is a business-oriented language. Like that's
mm,
literally what COBOL expands as. So
mm,
in that case, it's easier. The rules, business rules, and so on can be extracted much more easily. If you go
mm,
further back, like a code that is written in assembly language or something like that, it's very low level. So extracting business rules from there is really hard. So that can be a big challenge. And the in that case, a business rule extraction mostly depends on how well commented the code is and so on. Second thing is that code that's highly interlinked, like older languages often have things like go-to statements and so on, and that can be
mm,
really hard to parse through. Like modern
mm,
languages do not have such conventions. So those kind of things can be uh, things that trip up large language models.
mm.
So you have to be careful around those kind of things.
Okay. And this, problem slash opportunity of code modernization, uh, it sounds as if it's a big company, big enterprise problem. Is that right, or is that problem across the spectrum of company sizes that you've seen?
Largely a big company, big enterprise. The reason simply being that they have existed for that long. It's very unlikely that a tiny company
All
would
right.
exist. A smaller
Mm,
company, I mean, if a company has come around, let's say in 2000s, the code
mm,
would be largely modern. And in case they do want to modernize their code in any way, like suppose somebody wants to go from Python to Java or something like that, usually it's a
mm,
much easier task. I mean, for a variety of reasons, like generally modern languages are much more, there is a larger amount of code base to train on. So
mm,
LLMs tend to do, or code generation models tend to do much better on that. A
mm,
second thing, that the people who wrote the code may actually be around. I mean,
mm.
if you want Java developer, there are literally millions to choose from. I mean,
Yeah.
not ignoring the challenges of hiring good people, but
Mm,
it's very different when you are trying to go for a legacy language where it may be much more difficult to find the right people.
mm,
So the smaller companies do not typically face this kind of an issue. It's generally large enterprises with uh, where you have reasons why the code has been working for that long, like regulatory reasons. Sometimes people don't want to mess with something that's already functioning and so
mm.
on.
Okay. Okay. Got it. And given that is the case, like what kind of companies or solutions do you think will capture most of this opportunity or solve this problem largely? Would it be internal? Would it be SaaS products? Would it be, consulting companies? How would that play out according to you?
The kind of companies that I see with these kind of problems are typically companies like uh, the kind of old boring companies in a sense, like
Mm,
for
mm,
example, banking, insurance, aviation, things. companies like those. So they tend to have systems that go back that way. The early adopters in the computing space is the ones
Mm,
that you're looking for when you look for these kind of problems. Consulting companies to a far larger extent, simply because they tend to have shorter cycles for working with code. Most consulting companies, I
right.
believe, would not be old code to work with. I mean, except
Hmm.
for the clients that they work for, which
Hmm.
is a kind of work that Mphasis tends to get.
Yeah.
But uh, so yeah, the ones that I
Okay.
would be looking at are companies like the financial domain is a big one. They were
Big
among
one.
the early adopters of
Hmm.
this. And then companies like aviation and so on. Uh,
Hmm.
a lot of companies that have that were early into the networking space. So where a lot of, I mean, you have a large number of offices distributed around because they needed to coordinate them. They had earlier systems for doing it, and then those systems have continued to work through. So those kind of places.
Okay. And so for example, let's say a large financial institution has a problem like this.
Hmm.
What is in a post LLM world? What
Hmm.
do you think is their approach solving it? Do they do it internally? Do you see new SaaS tools coming out to solve code modernization, or do they call consulting companies to solve it for them? Like how do they turn to for help?
Yeah, it might be a mix of multiple approaches. Some
Mm,
companies have very strict guidelines around how much can you expose code to a third
mm,
party,
mhm.
because of privacy, secrecy, other kinds of things come in as well.
Yeah.
Uh, but most companies will have a multi-pronged approach to it. They would have an internal team that firstly triages maybe code that is easy to work with, code that is really hard to work with, and so on.
Mm,
You might look at tools. There are automated tools for doing it, work with LLMs or code generation models internally, and then you work with other companies like on pieces that they cannot handle. So usually it's not I mean, it's not a monolithic or one-shot operation that you hand it over. There may
mhm,
be companies who go with that if your code is modular and you can I mean, it's okay sending it out to a third party. Oftentimes, firms that have a huge amount of proprietary data or so on may have reasons beyond just privacy, like sometimes regulatory reasons also, that they cannot uh, send it out to others. So they might want to, like, even if a third party is involved, third party might be asked to come inside the organization and work completely inside, isolated
mhm,
from the outside world, rather than send their code outside and so on.
mhm,
So, yeah,
mhm.
that's how it might happen. But it's very case specific and depends on everything from what the industry is, the size of the problem, like how much code are you dealing with, what is
Right.
the uh, end goal, like do you one part of the end goal is like, do you want to make it more secure, or do you want to move from, say, one type of computing, like let's say you want to move from mainframe to cloud or something like that,
Mhm,
or are there other reasons at the same time why you're trying to do this? So
mhm, mhm.
there's a number of factors
Okay.
involved. Given that it's not a super common problem, uh,
Mhm.
each will have its own nuances to consider.
Right. Okay. So given what you just said right now, this is so super specific to each company because most of these companies you mentioned are highly regulated and all that. So,
Mhm.
are we looking at scenarios where literally every single instance of this has their own fine-tuned LLM for their code based?
Mhm.
That's
You,
how. Mhm,
in general, that's not the case. That's
mhm,
not going to be the case. Like, you
mhm,
could have it in certain specific cases, but what you want is a like, the reason it won't be the case for fine tuning your own model on every particular kind of use case that you have is
mhm,
that models require data to train, and if you have to create the data yourself, that is a
mhm,
large amount. So generally
mhm,
what you want is, let's say, uh, companies that have trained the data on large amounts of public data, and
mhm,
you work with the trained models. Maybe you might do a bit of fine tuning yourself, or some level of one shot or a few shot learning using prompt engineering. But
mhm,
usually you would not want to retrain the models yourself. It's not that cost effective to do that. It is
Hmm.
possible to do it, but generally that would not be the approach. So you would want to find a model, find a code generation model or a code understanding model that works well for the languages that you're dealing with,
Hmm.
and work with that. In case you have a really esoteric language that is not included in the code model, then you might want to retrain it. But generally, that is not the case. Like,
Yeah. Okay. Okay. And one of the use cases you mentioned earlier was the whole on-prem to cloud or mainframe to cloud kind of migration. Is that the largest trigger to code modernization, or are there other things like compliance and things like that?
uh, I'm not sure if that would be the largest. Like
Hmm.
the other things like compliance and so on also matter. A big factor is cost as well. Like mainframes are much more expensive to
Mm.
run and maintain.
Yeah.
Also flexibility. Like you might be
Hmm.
tied to a mainframe provider, whereas with clouds you have much more flexibility in terms of who you can choose to work with and so
Yeah.
on. Um, but security can be a big one. Sometimes it's just that your business is increased significantly and the older system uh, is having difficulty keeping up with the workload. So with a more flexible system like a cloud provider where you can ramp up or ramp down the amount of resources you have to deal with flexible loads and things like that. So flexibility is a big one as well.
Okay. Okay. And for a CIO of a large organization considering something like this, what would you say are the important, factors for them to think through before embarking on something like this?
Oh, okay. So that's an excellent question. There are certain things that you might want to look at before you embark on this is have a timeline of how long do you think this might take? Like have
Hmm.
a good idea of uh, what you're going to be like how rapidly you're going to be able to achieve something like this.
Hmm.
And you have an internal team that looks over all the code that you have and uh, be overall, I mean, don't be super optimistic. This is a complex project. Any kind of a large uh, code modernization is a fairly extensive and large project. So uh, take that into account. It's not simple. There are going to be things that you did not expect to find.
Hmm.
Uh, Beyond that, have a realistic idea of what you want to achieve from that,
Hmm.
and how it fits into your overall organization's ecosystem. Like,
Hmm.
and what another big one is that oftentimes you might want to not just modernize the code, but also bring in new functionality and so on.
Right.
So it's a good time to do that, but also be aware of what how it might change the timelines around this.
Got it. Got it. Makes sense. And um, uh, pre-LLM, right? Was there any automation at all to this, or was it completely manual? How?
So
Yeah.
in a way, like if you look at something like say a compiler
Mm.
is a translation thing. It goes from high
Mm.
level language to low level language. So
Mm.
similar to that, there were many other systems that did uh, similar kinds of things, but not for super large pieces of code, but they could handle many kinds of code. I wouldn't call it modernization because it wasn't converting from a older language to a modern language, but code
Mm.
translation in a sense.
Mm.
And
Mm.
depending on the languages, it could work reasonably well.
Mm.
So there are many tools that do that, like particularly tools targeted from like things like C to Java or Java to C and so on. And most of them work on like taking the code as smaller pieces of code and uh, and converting it accordingly. Sometimes they might be very low level, like converting it almost at a line by line or a few lines level. So the generated code, as I said, is not exactly the kind of code that would be highly maintainable. Like you can look at it and see that it's machine generated code. It's not super readable, but
Mm.
the advantage is that it does work with a new language. Another thing that is another way of tackling it is there are systems that do it in a black box fashion. So they don't actually look at the code at all. What they would look at is the input and the output. And then you try and build a system that, given this input, produces the same kind of output. So they have not
Mm.
looked at the internals of the code at all. They've treated it as a black box.
Mm.
And the system just tries to make sure that the inputs and outputs are similar to what you would have expected from the original code. And that's
Hmm.
another interesting way of doing it.
Hmm.
So there are, it's not exactly that LLMs are the first attempt at automating
Yeah.
code translation or code modernization. There have been
Hmm.
lots of attempts. LLMs do have some advantages that other systems don't. Like
Hmm.
uh, one major part is that LLMs understand language, and code is essentially language.
Hmm.
So they can understand long range structures and so on. And with recent advances, like over the last couple of years or so, when we have seen very long context lengths. So the context length is the amount of context you can give to the large language model, and that has
Hmm.
gone up from like a few hundred tokens to now literally millions of tokens. That
Hmm.
means that you can give fairly huge amounts of code base to a large language model and query it in different ways.
Yeah.
So that means that the model can do things that was simply not possible with older systems.
Hmm.
Second and significant part is that you can the model, in a sense, to anthropomorphize it, understands the language. So you can ask the model to, what does this particular piece of code do, or how does this fit into the overall code, and it can answer those kind of questions. Sometimes it hallucinates, so which is why you still need the SMEs and so on, but
Hmm.
they can often do a great job, and they're continuously getting better at it. Like nowadays, code models are at a point where things like lead code and so on, they can do at a human level or even better than an expert level in some cases.
Hmm.
So, but those are fairly specific small scale problems, and these are larger scale problems. But the large language models do have many advantages that the earlier ways of translating code do not. It's not that the older ways simply are not useful anymore. They
Hmm.
have their points in certain specific niche cases, but
Hmm.
this is a new way of doing things, and it has significant advantages that were not there earlier.
Hmm.
And one of the things I want to point out is that uh, in many ways, for the kind of code that is written for enterprises, like a lot of it is boilerplate code, working around regulations and so on, that does tend to translate reasonably well. It's not like it's not, say, toy problems or uh, the kind of code that you might find in like a coding competition where you want to, write in a highly constrained way or make it look clever or things like that. Like essentially,
Hmm.
this is something that does a particular kind of work, and you want it to be clear, reproducible, and all of that. So those kind of properties make it well to work with. I mean, make it easier to work with for a language model.
Hmm. Okay. Okay. And if you have to think about the efficiency because of LLMs to do modernization, how do you think about it? I know it's very difficult to put a number to it, but if let's say in the pre-LLM world, it took 36 months to modernize a specific code base,
Mhm.
with LLMs, what does that 36-month look like? Is there a way to think about that?
Yeah, that's actually a very good way to think about it. Like overall, when you're doing a large project like that,
Hmm.
at a high enough level, you can think about it in terms of like how much of an additional savings do I get compared to you're not using this method.
Hmm.
And I would say, uh, based on our experiences, it might be anywhere from 20 to 60%, depending on the type of code you're working with,
Hmm.
depending on other factors like languages matter a lot.
Yeah.
Doing it with like older assembly language like TPF or things like that, the savings would be lesser because assembly language is harder to work with. If it is
Yeah.
COBOL, it would be better. If it is languages, sometimes you have other languages. Like for example, if you're translating from Java or something like that, it's much easier.
Yeah.
Uh, so yeah, like it depends on that, but you do get some savings at all levels.
And the last question I had, Farhat, was that, and this is not just specific to modernization, but just broadly code generation as well, which is there is one school of thought which says that because of the LLMs, 10 times more code is going to be written, 10 times more applications, 10 times more tools because of that same people. There's another
Mhm.
school of thought which says that no, the people requirement is going to come down, but it's not going to be 10 times the amount of code. But so where do you fall in? How does one think about it?
Uh,
Uh,
my thought about this, and this is just my thought,
Yeah,
is
yeah.
it will mean a lot more code gets written. It's simply
Mm,
because it's easier to write code. Like whatever is easier tends to get done.
mm,
So say in the old era, if you wanted to do something, let's say you wanted to write you wanted code that did something specific, it's
mm,
possible the way you would go about it is look for code that's already been written and try to modify it in a way that it does what you wanted it to achieve. Like maybe look at
mm,
open source code, or go to GitHub, find something that does even partially what you wanted to achieve and go from there. Now in
mm,
the modern era, instead of doing that, you might just ask the LLM to do what you specifically want
mm,
done. And that means
mm,
that you have written de novo code that now does that. It's
mm,
possible that that code is doing things that other code already exists in, doing similar things, but
mm,
now you've rewritten it. So it's quite possible that the total amount of code that is written in the world will increase significantly.
mm.
A lot more code will be written by, a second thing is a lot more code will be written by people who don't understand the code as such. Like,
Right. Mm-hmm.
you would just write, I mean, you would just ask it to do something specific. Like, let's say somebody wants a Excel macro to do something else. Initially, they might have tried to do it in a not sufficient fashion or something like
Mm,
that. Now they would just fire off a command like, okay, this is what I want done, do it. And it
mm,
does it. You don't
mm,
understand the code, but it does what they want. They know what they want though. So then they
mm.
can test the code written is correct, even if they don't
Right.
understand the internals of the code. So
Right.
that means that a lot more people will be writing code. I mean,
Mm,
or generating code that were not doing that before. So I think
mm.
it's a huge number of people, huge increase in the amount of total code that will be written.
Yeah.
So overall, I feel that the amount of code in this world will increase significantly.
Okay. Okay. I know I said last question, but I'm sorry, I have one more follow-up question on the last thing you said right now, which is, you spoke about how the person who wants the app, and let's call that person the business user,
Mhm.
and you're saying that a lot more code will be written because the business user will be able to just do natural language and get what they want. But I'm sure, like, you agree that we have seen that getting what you want from the LLM needs a little more than natural language, like a very technical natural language to get something really, really useful out of an LLM. So there is obviously this new job role of, prompt engineers, prompt creators coming up out there. So what do you see in the industry? Are traditional data scientists and ML engineers needed to have the skill of writing super specific technical prompts, or is that being carved out to specific roles who know about vertical as well? What is happening?
Uh, I don't think you need to have the knowledge of creating super specific prompts. Like one
Mm,
interesting thing with LLMs is you can ask the LLM to create the prompt for you. That
mm,
also works reasonably
mm,
well.
mm,
So I think that that skill will be less and less required. Like prompt engineering as such may not be, uh, in my opinion, be a super useful skill to have going
I see.
forward, because
Mm-hmm,
LLMs are getting better and better at understanding
mm-hmm,
natural language, and
mm-hmm,
also chain of thoughts and things like that allow the LLM to even ask you query back with you. Like for example, is that specifically what you wanted, or
mm-hmm.
like that. So edge cases are taken care of.
Question completely. You're saying that it's going to be getting progressively much easier to write these prompts. So it's not a super specialized skill that one is going to expect from.
Yeah, so one way I think
Yeah.
of someone else is like having a somewhat smart assistant with you, and you talk with them just like you talk with an assistant, like that this is what you want done. And
Mm,
in case what you have specified is not completely clear, they can come back and say like, this what you wanted, or is that what you wanted? And you
mm,
can clarify that. Or you give a few examples like this is what I'm looking for, something similar to this, and the model can go ahead and do that for you. Uh, so yeah, like as the models understand, uh, get better at many of these tasks, and they're continuously getting better because all the companies that are operating these large models from like say OpenAI or Gemini or so on, they get a large amount of data from people who are using these. So
mm,
you're continuously getting data about how people are using these prompts. Every time you like rewrite a prompt, they understand like, okay, the past one did not work, things like that. So overall, these systems are continuing to get better, and eventually, you would expect them to be as good as, let's say,
mm.
a reasonably smart employee that you might have. So,
Got it.
and Another part is like sometimes people are afraid, like, okay, does that mean that all jobs will go away or so on? I don't really see that for now, simply
Mhm.
because what it means is that the amount of work itself will increase.
Mm.
So there is likely to be a requirement for more people who can understand and work with them rather than less in a way.
Yeah, makes sense. Thank you so much, Farhat. This has been extremely helpful. Really appreciate the time you took to do this.
Thanks, Vinny. This was enjoyable. And thanks for having me again.